Of all the pillars of traditional scientific thought, including biology, chemistry, mathematics, and physics, it arguably was physics that guided most of what happened to human civilization in the 20th century. With one Albert Einstein at the helm, working at the beginning of the 1900s, we gradually came to refine our understanding of the physical world around us. And while not everything has played out for the best, such as the splitting of the atom and the development of nuclear weaponry, it was that early work by Einstein and others that laid the foundation for things like today's particle accelerators, fusion reactors, nanotechnology, and even gene therapy. What's perhaps surprising then is that all predictions are that we're still only just at the beginning. The Large Hadron Collider at CERN is arguably the most influential facility in modern physics, although it is by no means the only particle accelerator around, with Fermilab being probably the most famous in North America, for example. Regardless, we can and should expect a steady stream of discoveries to emerge out of these spectacular bits of kit. While the Higgs boson God particle is a tough act to follow, researchers are hot on the heels of yet more previously undetected particles, such as the axion, which we took an in-depth look at in another recent video. More broadly than that, however, those at CERN are perhaps most interested in what are known as supersymmetric particles. This all has to do with theories on supersymmetry, which, according to CERN, is an extension of the standard model that aims to fill in some of the gaps, predicting a partner particle for each particle in the standard model. It's expected that these partner particles, which were around in the very first instances post-Big Bang, should then be generated under certain conditions at CERN's LHC, and therefore it's only a matter of time before we hear more about them. If the LHC is a key facility in physics, however, then nuclear energy is a key concept. It certainly has a checkered past, thanks to nuclear weapons, nuclear plant disasters, and historic mismanagement of nuclear waste. But nevertheless, times could soon be a-changin' in the nuclear sector as the world searches ever more desperately for suitable energy supplies. With fossil fuels on the way out, and despite the various benefits of wind, solar, and others, increasing numbers are predicting a second coming for the fusion reactor. There are possible changes in the footing too, though, including a debated switch to thorium rather than uranium-based nuclear power, which could bring many of the positives without the negatives, such as without its use within weapons. Now, in whichever guise, it's not as though nuclear energy has ever really gone anywhere. In many countries, including the US and France, it already reigns as a major energy contributor, but it has struggled to shake its dirty and dangerous reputation, with a greater emphasis placed on safety and with innovative plans to more safely dispose of nuclear waste, including various initiatives to bury it further down than ever before, and perhaps even to within the subductive realms of Earth's mantle. It could be that someday soon the world's distrust of nuclear will dissolve. Consider too that next-gen nuclear engines are in development for space travel as well, and it might even become the trendiest option around, for better or worse. But really, even nuclear energy could soon become old hat in the shadow of our third potential breakthrough, the capture and utilization of dark energy. Ever since we've understood that the universe is not only expanding, but that its expansion is also accelerating, the quest has been on to get to grips with the mysterious something, dark energy, that's fueling that acceleration. Get a hold on that level of power, and really there could be no limit to what we might achieve. So how close are we? At present, not particularly close. But if the history of physics has taught us one thing, it's that can change very quickly. According to some predictions, dark energy could even represent a fifth fundamental force known as quintessence, a kind of power inbuilt with the universe that can be attractive or repulsive, and is then perhaps crucial to understanding how the universe began and how it will end. In fact, if scientists do hammer out a clear definition of dark energy in the next few years, then we could all finally come to know the ultimate fate of the universe. Big Rip, Big Freeze, Big Bounce, or any other model. That would clearly be a major moment in time. But of course, physics isn't always all to do with only the very biggest mysteries of reality. There are countless more practical applications for life just on Earth, and one that could become especially useful in the coming years is physical oceanography. It's by now well known that our oceans are seriously underexplored, which means that they're still shrouded in mystery. But a developing physical approach could well turn the sea into something that's understood in literally minute detail, down to the particles within and the tidal forces at play. We can already to some degree map the waves, but by continuously crunching physical data into contemporary computers, soon we'll no longer be guided by vague oceanographic maps with just a few arrows pointing here and there, but instead we'll have all the analytics we could hope for. Water temperature, salinity, and porosity, the sea's chemical makeup, and its physical impact on the atmosphere it laps up towards. These are all processes that the Earth cycles through day after day, minute after minute, but physical oceanography aims to take the guesswork out of monitoring them. Approached in this way, it's as though the water on Earth is a machine in itself, ticking along and hopefully without any major problems. Physics can open up that machine though, potentially to maintain it and perhaps even to improve it. In the future, it's hoped that a physical approach will enable us to better look at such fundamental processes at other locations away from Earth too, including within stars and within our own sun. The physics of plasma has been a hot topic for more than a century now. But although plasma is recognized as the fourth state of matter, after solid, liquid, and gas, and although it's also the most abundant ordinary matter in the universe, there's still so much we don't know about it. From the lightning that cracks through our atmosphere to the accretion disks that seem to leak out of black holes, plasma is all around, and physicists are trying their best to tame it. So far, we have plasma propulsion methods being trialed during high-end rocket launches. But beyond plasma television screens, it can feel as though there hasn't been much of a crossover into everyday life. In the coming years, that could well change, with scientists and engineers capitalizing on the variability of plasma products. We could even see plasma medicines developed in some cases, in fields such as dermatology and dentistry, and increasingly within the future treatment of cancer. But finally, and to what arguably links all of these other examples, the search for a theory of everything. Otherwise known as the ultimate theory, this would be an unbreakable universal framework to fully and seamlessly explain reality. At present, physicists have general relativity and quantum mechanics to work within, and both make a whole lot of sense within themselves. However, science is yet unable to link the two completely into one single model. Perhaps the simplest way to do that would be to discover an understanding of quantum gravity, that is, gravity as per quantum principles. But so far, there's no such thing. In the minds of some, string theory is our best bet toward achieving this holiest of holy grails. According to string theory, at the very base level of reality, there is a mesh of tiny vibrating strings, humming away and steadily rendering all that we see, know, and feel. It's an unproven framework, but if it were correct, then it could mean that there's as many as 10 dimensions to existence, dramatically expanding our horizons beyond the 4 that we currently comprehend. Will a theory of everything actually arrive during our lifetimes? Only time will tell. But there is hope that it, along with all the other predictions covered in today's video,